So consider these programs. We have to find out what is the output of these programs. So first program is int main, int a is equal to 032, and we have a printf statement. And this printf statement is printing this output in %d, right? So this kind of programs looks very easy, but there's a trick here. So whenever we start an integer number with 0, then by default this the C compiler takes this integer number in octal format. So this is in octal format, and when you are printing this output, then you are printing this number in decimal format. So decimal format, so it is, so you are printing this output in decimal format, right? So the number is 032, and if you convert 032 from octal to decimal, then you can find out the output of this program. So the first number is 2. So to convert it, you have to multiply this 2 with 8 raised to power 0, plus this 3 with 8 raised to power 1, plus this 0 with 8 raised to power 2, but that doesn't matter here. So the output will be 3 into 8 plus 2 into 8 raised to power 0, which is equal to 24 plus 2, which is equal to 26. So this program will print the output as 26. Okay. Now check out the next statement. So in this next program, we are having an integer number, and then we are printing a character value of this integer number. Okay. So you have to print this integer number into a character. So do you know the size of an integer variable in C language? The size of integer variable is 2 bytes in some system, and it is 4 bytes in some system. So it is 4 byte in 64-bit systems, and this is 2 byte in mostly in 32-bit systems or some old computers or old operating systems basically. So it is 2 bytes in some old operating systems, right? So let us assume that integer in these tutorials are of 2 bytes only. So the number is int a is equal to 65. So how this integer number a is represented in binary format? So with by using 2 bytes. So we are having these 2 bytes. Okay, this is the first byte, and this is a second byte. So let us suppose this is LSB and this is MSB. Okay. So this 65 is represented as 1, 0, 0, 0. This is 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, 2 raised to power 4, 2 raised to power 5, and 2 raised to power 6, and this is 2 raised to power 7. So this is the first 8 bits, and this is the second 8 bits. So as this is a positive number, therefore the sign bit is 0. So 0, 1, 2, 3, 4, 5, 6, 7. So this is the second 8 bits. So we know the size of a character is of 1 byte in C language. Therefore, whenever we are going to print this statement, this program, this character value will only take this first byte, and it will print the related ASCII value for this first byte. So this first byte is representing the number 65, and the ASCII value, corresponding ASCII symbol for the 65 is capital A. So this program will print the output as capital A. Okay. So consider the next program. So in this next program, we are having a number int a is equal to 3 to 1, right? And this, I'm printing this 3 to 1 into a character variable. So as you know, in character, the size of a character is of 1 byte in C language. So if you are going to print this number in character variable, therefore it is only going to take first byte of this integer variable. So let us see how this integer number a is equal to 321 is represented in binary format. So it is represented something like this. This is the first byte, and this is the second byte. Okay. So just for ambiguity, so this is the first byte and this is the second byte. Okay, so this A321 can be represented something like 256 plus 65, right? So it can be written as 100000010000000, and this is a sign bit. So as it is a positive number, therefore the sign bit is 0, right? So now I'm printing at a percentage C. So this percentage C will print the first byte only, and the value stored in first byte is 65. Therefore the corresponding ASCII value of 65 is capital A. Therefore this program is going to print capital A. Now in the next program we are having A is equal to 0, 1, 1, right? And then I'm printing the value of A with percentage D, and then I'm printing the value of A with percentage I, and then I'm printing the value of A with percentage C, right? So as you know, this 0101 is because this is starting with the number 0, so that means by default C compiler is going to take this number as an octal number, and then when we are going to print this number, then this number will be printed in decimal format, right? So the number is int A is equal to 0101. So let us convert this octal number into decimal format. So the number is 0101. So we multiply this by 8 raised to power 0, this by 8 raised to power 1, and this by 8 raised to power 2. Therefore the number becomes 1 into 8 raised to power 0 plus 0 into 8 raised to power 1 plus 1 into 8 raised to power 2. Therefore the number becomes 1 plus 0 plus 64, which is equal to 65. So as again this is a binary, this is a decimal equivalent for some ASCII character. So initially I am printing it with the percentage D sign. So this percentage D means I am printing this number into decimal format. So this is going to print 65, and this percentage I is also used for integers. So as we can use percentage D and percentage I alternatively. Okay, so this is a scanf statement. Okay, this is not a printf statement, this is a scanf statement. Okay, now let us assume that user, this is a printf statement instead of scanf statement. Let us assume this is a printf statement because I can cover the scanf statement in the next line also. Okay, so this is a printf statement, and for this printf statement I'm printing the value of A with percentage I, and whenever we are printing the value with percentage I, then percentage D and percentage I, both this percentage D and percentage I behave the same way. So that means there will be no difference in the output in both these cases. But whenever we are going to scan the value of I, then there will be a difference between the outputs, right? So which we will see in the next part. So we are having printf percentage I is equal to A. So the value of variable A is 65, therefore it is going to print 65, and this statement is going to print again capital A. Okay, so now let us see the next part. So here we are having a integer A variable. So this is A. Okay, and in this integer A, first of all we are scanning the value of A with percentage I symbol. That means we are asking user to enter the value, and let us suppose the user has entered 0x56. Okay, now as I already told you, this percentage I is used for integers. So when I'm scanning the value of this variable A, so whenever I'm printing the value with percentage I and percentage D, there's no difference, but whenever I'm scanning the value, then there's a difference. Okay, so when I scan the value with percentage I at A, and this number is containing some X value, that means it is going to take this number in hexadecimal format. So it is, this number will be in hexadecimal format. Okay, what is the decimal equivalent of this 0x56? So if you convert this 0x56 into a decimal, then this value is basically 86. So you can see how to convert this value. So this is 6. So multiply this by 16 raised to power 0 and this by 16 raised to power 1. Okay, then this becomes 5 into 16 plus 6, which is equal to 80 plus 6. Therefore 86. So this statement is going to take the value of A, and the user entered the value 0x56, which is equivalent to the decimal value 86. Now in this printf statement, first of all I am printing this value with %I, and then I am printing this value with %D, right? So remember, we have scanned this value with the variable %I. Okay, so whenever the user is going to print this value, so it is going to print 86 space 86, because it is going to print the decimal equivalent of this number. Okay, and now in the next scanf statement, user is entering the same value again, but the difference is here, instead of doing %I am taking the value with %D, right? And this %D is, in this case, the %D behaves a different way. So this is a scanf statement. As I told you, in printf statement, the %I and %D behaves in a similar way, but in a scanf statement they behave differently. So here in %D, the user entered 0x56, but because this x is a character value, so this variable A is only going to take the first value, which is 0. Therefore the value which will be stored now in this variable A is 0, and this now it is going to print the output. So the output will be 0 space 0. Okay, so this is the difference between the %I and %D. So I'm repeating again. Whenever we are using the %I and %D in a printf statement, then there's no difference in their working. But whenever you are using %I and %D in scanf statement, then there is a difference, right? So in this case also, for example, the user has entered a hexadecimal number. Now let us suppose, instead of entering a hexadecimal number, the user has entered a octal number. So in octal number, how this %I and %D are going to behave? Okay, so let us suppose, instead of entering 0x56, the user has entered 0101, right? So as the user has entered 0101, which is basically I took this value from here, and the equivalent decimal value for this 0101 is 65. So as the user has entered a number which is starting from 0, therefore this %I is going to assume that this number is so therefore this %I is going to assume that this number is basically a octal number. So whenever you are going to print the value of this number, then this statement is going to print 65 and 65. Okay, but if we scanf the variable A with the %D, and the user has entered the number 0101, now in this case the user has entered a number starting with 0, but this variable is going to assume that this number is a decimal number. So now in this case the output will be 101 space 101. Okay, so this is the difference between the %I and %D. So make sure you don't skip this part. Okay, now let us see more examples. Now let us see. So this is a program. These are the programs. We have to find out the outputs of this program now. So these questions are based on if-else statements. So what is the basic structure of a if-else statement? So the basic structure is if some condition, and if this condition is true, then this code is going to be executed, and if this condition is false, then this code is not going to be executed. Okay, so then what is when do you say this condition is false? So whenever we are going to enter some condition here, for example, the condition is A equivalent to double equal B, or A less than B. So these are the conditional statements. So the outputs to this conditional statements are 0, 1 and 0, and this 1 means true and this 0 means false. So that means instead of entering this A double equal to B or A less than B, here I can also enter 1 and 0. So in case of if-else statement or for loop or while loop or any other statement where we are basically acting upon the condition, so in these cases this this statement, this is false if the input here is 0 and it is true otherwise. Okay, so if you execute these programs, so the first condition is if 0. So if 0 means if false, and if false means this statement is not going to be executed, right? So the next statement is if 1, and if 1 means true, so it is true, therefore this statement will be executed. So it will print ugcnetlectures.com. okay, so in the next line we have if -1. So whenever the user types any number other than 0, right, so that means it is true. So if the user entered if -1, that means this is a true condition and it is going to print this statement. Okay, and the next statement, it is if 0. If 0 means it is false, so this statement will not be executed. And the next statement is if -86. So if -86 means it is true, so this statement will be executed. And if 86 means this is true, therefore this statement will be executed. Okay, so now check out this program. In this program we are having two variables a and b. The value stored in a is 5 and the value stored in b is 6. Okay, so let us suppose these are the variables. The value stored in a is 5 and the value stored in b is 6. Okay, so first of all they have done if a single equals b, right? And in the next statement we are having a double equals b. So what is this a single equals b? That means I'm copying the value of b into the variable a, and then it is going to return that value. Okay, so that means I've copied 6 into the variable a and it is going to return the value. That means this statement is going to be if 6, and if 6 means it is true, therefore this statement will be executed. Okay, now the value of a is 6 and the value of b becomes is also 6. That means the value of a is now changed. Okay, so now if we execute if a double equals b, that means we are comparing their values and their values are equal, therefore this statement becomes true, therefore this will be executed. Okay, right, now check out this program. In this program we have taken the value of this a variable is of float type and we are taking the value 5.66. okay, and then we are printing this value with %d. So in this %d is used for integers, therefore it is going to ignore this point part and it is only going to print 5. Okay, right, so now let us see the next programs. Now check out these programs. Okay, so this program was asked, this question was asked in UGCNet 2014. Okay, and the options were actually it was 126, I guess. Second option was 127. Third option was 128. Fourth option was 129, and maybe the fifth option was 130. I think there are only 4 options. So I've written one option extra. I think this one is extra. Okay, so let us see what is the output of this program. Okay, so the value of variable a is 128. Value stored in the variable a is 128. Then we are executing this printf statement, and in this printf statement we are having two things. One is it is 1 plus a plus plus, and this a plus plus is post incrementation. So it is post incrementation. That means first of all I'm going to use the value of a, then I'm going to increment the value of a. So it is 1 plus the value of a is 128, then it is going to print 129, and at the same time then it is going to increment the value of a, so value of a becomes 129. So therefore the output to this program is option number D. Okay, so now check out the next statement. So in this next statement the value stored in the variable a is 0. So in this next program the value stored in the variable a is 0. Then I have done if a plus plus, and this a plus plus means this is a post incrementation. So it is post increment. So post increment means first of all I'm going to use the value of a, then I'm going to increment it. So it means it becomes if 0, right? and if 0 means this value, this condition is false, and then it is going to increment the value. Therefore the value after executing this statement, the value stored in A is now 1. Okay, so in next statement it is, they have written if A means if 1, which means true. Therefore this statement will be executed and it will print the value of A, so it will print 1. Okay, so in the next statement I have pre-incrementation. So that means first of all I'm going to increment the value of A, then I'm going to use it. So the value of A after incrementation becomes 2. So it means if 2. So if 2 means true, therefore this statement will be executed and it is going to print 2. Okay, so in the next program I have printf hi, then I'm doing %d, and then there's a statement as printf hello, right? That means within this function I'm calling this function again. Okay, so this function is going to print, first of all it is going to print the value this hello, so it is going to print hello, then it is going to print this hi, and then this %d is basically is going to print the value returned by this printf statement, and the value returned by this printf statement is the number of characters here. So the number of characters are 1, 2, 3, 4 and 5. So this is 1, this is 2, this is 3, this is 4 and this is 5. So there are 5 characters, so it is going to print hi, hello, hi, and then space 5. So this is going to be the output of this program. Okay, so in the next statement I have if printf yellow. Okay, so it is, first of all it is going to print the yellow, so yellow. So the value which will be returned by this printf statement will be 1, 2, 3, 4, 5, 6. So the value which will be returned by this printf statement will be 6. So that means it becomes if 6, and if 6 means it is true. So therefore it is going to print this statement. Therefore the output will be yellow, it printed. Okay, now let us see some more programs. Okay, now let us see this program. So in this program I'm having int I is equal to 5, right? So actually this program I've seen this program somewhere online in some Facebook groups or I think some website. So they have written a wrong answer for this program, and I'm going to explain why this answer is a wrong answer. Okay, so the value of I is 5. Actually we are having 4 options for this program, and all these 4 options are wrong, because there should be one more option which is undefined behavior, which should be undefined behavior. Okay, and in some books they have also given an option like implementation dependent, etc. So they have given some this option also. So whenever we are going to execute this program, then how the user will think what should be the output. Okay, so I'm just thinking how people will think the output. So the value in variable A is 5. So in this printf statement, first of all, here I am printing the value of I. So first of all, it is going to increment the value of I, then it is going to print the use the value of I. So the value of I is 5, therefore it is going to increment it, and it is going to make it as 6. Then I am going to print the value of I, therefore first output will be 6, and then in the next statement I am printing the value of I, which is 6, and in the next statement, first of all I am using the value of I, then I am incrementing it. So it will print 6 and then it will increment it to 7. Therefore people will think the output will be 6, 6, 6, right? So there's no option as 6, 6, 6, right? So and what other way people might think of the output? Some people say that the compiler is going to execute the statement from this direction. So this printf statement is going to print output like I++. That means first of all it is going to print the value of I, then it is going to increment the value of I. So it is going to print 5, then it is going to increment as 6. Then in the statement it is going to print the value of I, which is 6. And then in this statement it is going to increment the value of I, then it is going to print the value of I, therefore it will make it 7. So it will be 7, 6, 5. So which is one option here, right? So this option is also wrong, this answer is also wrong, and this answer is also wrong. Both these answers are wrong. So actually the thing is, for this program, if they have given all these options, then all of these options are wrong actually. Any options with the numbers is wrong. Why? Because this program is going to have different outputs in different compilers, and this is due to this undefined behavior, as I've talked in the previous class. So there's something else called as undefined behavior. In this undefined behavior, whenever within a single statement I'm using the value of the variable, and at the same time and I'm also changing the value of the variable. So here I am basically changing the value of the variable in this statement, I plus plus I and I plus plus, and I'm using the value of I in all these three statements. So this is going to bring undefined behavior for the C program, for the C language, and any of the statements will be executed in any order. So if you execute this program in Xcode, then you will get some different output. If you execute this program in online compiler, then you will get different output. If you execute this program in Turbo C, then you are going to get different output. If you are going to execute this program in Dev C++, then you are going to get different output. So their outputs will not match, and it will confuse you. Why? Because of this undefined behavior. Okay. So this is an ambiguity in C programming language. So you can check out more details about this undefined behavior, and check out read the topic sequence point. So read with this undefined behavior, read this topic which is sequence point. So you'll get some idea why this kind of programs are going to give me different outputs and different statements, right? And this is implementation dependent. I've seen this option in some of the study material provided by the coaching institutions. So for example, I've seen the study material provided by the MEDIC, and they have given similar program like this, and they have in explanation they have written it is implementation dependent, but it is not implementation dependent because this is an ambiguity in C language. So the correct options should be undefined behavior or sequence point, right? So okay.